two-step equations, simplifying. So when we use order of operations, we multiply and divide before we add or subtract. But when solving, we're going to work backwards, which means we're going to go ahead and add or subtract before we multiply or divide. So let's look at the first example. The total cost of the hospital gift store was $13 and there's no tax. One item was $8 and two identical items were also purchased. What was the individual price of the identical items? So we're going to solve by using the equation below. So 2 times some kind of amount plus 8 is going to be equal to the 13. Now, when we solve, right, we're going to work backwards and we're going to go ahead and add or subtract first. So that means we're going to deal with these numbers here first. So we're going to go ahead and subtract the 8 on both sides, because essentially we want to get this x by itself on one side of the equation. So this just, right, cancels out. So now we have on the right-hand side 13 minus 8, that's 5. We're just going to go ahead and bring down that 2x. Now 2x is equal to 5. So now we just solve for x, right? And we can do that by dividing on both sides. So that's the next step, right? After we add and subtract, and we don't have to do that anymore. We just go ahead and, right, divide here. This just becomes 1, so that's just x. Now 5 divided by 2. We can leave it like that, or we can just go 2.5. Always feel free to get the calculator out. But as this is money, right, we would say the individual price, right, we could even write it as $2.50. So if you have two items that are $2.50, so that's $5 plus 8, well, that would equal to 13. So it checks out. Now let's do the next example. So example 2, we're going to solve for the following. We have 3x plus 4, which is equal to 13. Now we're going to go ahead and subtract 4 on both sides. We're left with 3x on the left-hand side. 13 minus 4, well, that's 9. Now we're going to go ahead and divide by 3 on both sides. The reason we do this is we get x by itself, because that just becomes 1, right? 3 over 3, that's just 1. Now we just have x, or you can say 1x, which is just x. Now 9 divided by 3, that's 3. That would be our solution. And we can go back and plug this in, right? 3 times 3, that's 9, right? So we have 9 plus 4. Now 9 plus 4, that's 13, equals 13, so it checks out. Right, we could do a really quick, like, little step like that to make sure we did it right. Now let's go on with the next example. So example 3, we're going to solve for p. We have 41, which is equal to p over 2 minus 9. Now we're going to go ahead and add or subtract first. But as we have a negative term, right, like this minus 9, we can go ahead and do the opposite and add on both sides. This gets rid of it on the right-hand side, right, because that just zeroes out. So we could just drop that down to p over 2. 41 plus 9, that's 50. And then we just go ahead and multiply on both sides. We do this because we want to get p by itself. We want to get this 2 gone. So we go ahead and multiply because we undo this division, right? Because then 2 over 2, that's just equal to 1, right? And so we have to do it the other side. And so then we're left with p on the right. And then 2 times 50, that's 100. So that would be our solution.